Welcome to the Collaborative Podcast. I'm your host, Spencer Krause. Our guest today is Moses Divaker. Moses is an aerodynamics engineer and employee number one at Archer Aviation. Moses, welcome to the pod.
Awesome. Thanks, Spencer. Appreciate you having me on.
Appreciate you coming on, buddy. Good to have you here.
Appreciate you having me on here. Yeah.
Moses and I just screwed up the last run of this intro we did, so cracking up over that. But good to be here. I think it's good enough. I think we can go in and do it.
Absolutely. Let's do it.
Cool. So, employee number one at Archer, obviously a pretty well-known company. How'd you get recruited for that role, and what's the ride been like as you've been getting into that?
It's been an incredible journey. I mean, we started out essentially very small company. We started actually in my graduate student lab. So that kind of goes into how I got started with Archer as well. So back in 2018, I was actually working for a small drone company in Gainesville at the time, and they had just closed their doors. And I was in grad school, trying to finish grad school. So I joined this research lab, and their main thing was building drones, UAVs. But the approach that they took, I thought was really fascinating. So one of the things they did in that lab was they were able to build and fly lots and lots of drones, kind of using like a very quick, prototype method, just kind of getting this thing out the door. Let's gain some learnings from building these things and iterate and build the next, class of vehicles based on the learnings that we did. Very empirical. So I saw that, and I was looking at, say, the market around the time, and I was like, one of the biggest things is, of course, in 2016, Uber Elevate dropped their white paper on air taxis. And it was always my dream to kind of work in this industry and build flying cars, air taxis, whatever you want to call them, eVTOL. There's still a kind of a transitional term for these kind of vehicles, electric vertical takeoff and landing vehicles. But I've always wanted to do that. And I saw these small UAVs, these drones, as kind of a stepping stone to doing that. And of course, it's really hard to build a large full-scale vehicle. It's very easy to build like these small drones, but essentially it's very similar in terms of its core technology. They're electric, they're stabilized with, flight computers, and they have multiple rotors. They have multiple, different things. They can take off vertically, transition to forward flight, and just become like normal airplanes. So it's essentially the same core technology scaled down. So at that point, I was like, hey, my lab, we can do this. We can build lots of these aircraft around. Let's see if there's anyone else that's interested in working together and trying to build this as well. So I went to a conference, AIAA Aviation in Atlanta, Georgia. And that's actually where I met Brett Adcock, one of the co-founders of Archer Aviation. And Brett was out there. He and his partner, Adam, had, they were kind of they were in the process of exiting Vetter. I think they actually just sold the company recently. So that was, they sold it and they were looking for their next big thing. And, that was this industry had really attracted the attention of both Brett and Adam. And they were there trying to meet people, trying to meet the best and brightest and try to recruit them to help get Archer off the ground. So when we met kind of in a hallway, actually. It was super random. I was out there and I was looking to meet people, and obviously so is Brett. So I just kind of introduced myself. I was like, hey, my name is Moses. What's your name? And he was like, oh, Brett Adcock. And we just started talking. It turned out we had a mutual interest in building these aircraft. So that meeting essentially became it helped actually begin the process of Archer's, formally having a relationship with the University of Florida. And at that point, they were, I think, funding a few other small, projects, here and there. And Brett brought me on as a contractor just to kind of work with him and work with both Brett and Adam, work together, and send him a bunch of designs. And we worked together over the summer. And come August, I think it was actually October, throughout October. So we met in June, and I was working with him, kind of on the side until October. And essentially, the pitch that, was what I made there was like, what, we've been working on this for a few months here. We've got, a bunch of designs. Let's go see if we can build these things. And I've got my lab here, and let's just try to make this dream become a reality. And both Brad and Adam, they decided to, used some, of course, their own personal funding, and they founded Archer, and they funded our lab. And what we did with that funding is we built a bunch of early prototype aircraft, and that's essentially when Archer got started. It was October of 2018. Funded building aircraft off of Archer Road in Gainesville, Florida, and those aircraft eventually became bigger. We learned a lot from those aircraft. There were a lot of deficiencies in the design that, through our flight testing, because we were rapidly iterating. We're like, okay, these things work, these things don't work. And then eventually, Brett and Adam were able to convince other investors to join on. Mark Laurie joined on. They were able to raise a bunch of money, and we were able to go take this from a very early stage, a bunch of grad students building these things, to having some of the best folks in the industry helping us out. And of course, we took all the learnings that we had from the University of Florida into our next generation of aircraft that we've built, and we're still learning today. We've built multiple full-scale aircraft. We've had makers flying its full-scale aircraft. Have Midnight, our non-certified Midnight's also flying right now. We're learning quite a bit of it, quite a bit from that to take to our certified product. So it's kind of the same concept, similar concept. Design, we build, we fly, we learn data, get some FAA data, and kind of iterate and build the next generation. So it all started in 2018 at the University of Florida.
That's awesome.
Yeah.
What are some of the kind of similarities and dissimilarities between like the eVTOLs and, I don't know, helicopter, for instance?
That's a great question. So eVTOL and helicopters. So traditionally, the way that helicopters operate is they're really loud, they're really noisy, and a lot of those noise sources come from the fact that there's when we fly our aircraft, we are wing borne, right? We are not generating lift with the rotors. We're using just passive, where the wings are generating lift, right? That itself is a huge thing. So we are able to not just carry the weight of the aircraft, but we're able to offload that to the helicopter. So to offload that to the wings, that will allow us to shut down a lot of our rotors. And when we shut down our rotors, it's going to be quieter. That's the first thing. Second thing is we are fully electric. And because we're fully electric, that also eliminates a lot of overhead in terms of maintenance costs. So for example, like you've got a gas turbine engine or a piston engine, and there's so many moving parts in these things. It's unbelievable. But an electric motor, an electric engine really, really simplifies that thing. We've just got a bunch of magnets, spinning around. And of course we have gearboxes on ours, but it's much, much simpler than, say, a traditional gas turbine or a reciprocating engine would be on a helicopter. So you've got the noise. It's going to be quieter. You've got the simplicity from the motor, from the engineering standpoint. And lastly, it is also electric, which is a huge benefit in terms of like when we think about what the future world we want to build in. Of course, there's a big push right now to reduce emissions. And of course, our aircraft is going to be zero emissions. So that's going to be a huge thing, I think, for a cleaner future where we're not, polluting the skies with, aircraft that are spewing, different, all kinds of exhaust chemicals, whatever. So I think it's overall, these things are what sets us apart from helicopters. And, I think we're obviously,
So it's a totally different vehicle.
Totally different vehicle, exactly.
Yeah. I mean, it's, and I didn't really think about this coming in, but it's effectively a transformer between, a rotorcraft and a plane. And then at the same time, you've also got the benefit of being electric, which you could electrify a helicopter. I'm sure it's been done before, even though I don't really know. But you still wouldn't get that benefit of being able to use the wing lift that you get from,
Yes.
This eVTOL.
Exactly. And that really is a huge benefit. It allows us to, like I said, we can fly, once things get better in terms of battery energy storage, we think that we should, we're going to be the superior aircraft. And it's, the VTOL paradigm is also primarily the reason why you see the V-22 Osprey, for example, now becoming one of the most, popular, aircraft in the armed forces inventory. So it's just, I think it's a much, it can do both missions, both a helicopter and an airplane, albeit, we can't hover as long as a helicopter could, but we can certainly fly farther and faster than a helicopter would. And we can't fly as far as an airplane would, but we can take off and land without having a runway. So it's, I think it's a pretty good sweet spot to be in.
Yeah, it's pretty awesome.
Yeah, yeah. Interestingly enough, is we see that same paradigm in the aviation, in the bird world, actually. So you have, obviously it's another creature that gets in the air, and on one end of the spectrum, you have creatures like the hummingbird, which are like really good at hovering,
Helicopter.
but yeah, exactly, like a helicopter, exactly. And the other end of the spectrum, you have this bird like the wandering albatross. The wandering albatross like requires like essentially like a runway to take off.
Oh, I
Like
didn't
it
know
needs
that.
to
That's
like
really interesting.
yeah, it's crazy. These things can run. They run down the road and then they flap their wings and they like get in the air. And of course, the albatross can fly over the world, no problem. It's got great efficiency. Hummingbirds, they burn a lot of energy doing what they're doing, right? But in the middle, you see birds that kind of had a mixture of both. And one of my favorites is actually the osprey. So the osprey is one of these larger birds. It can hover in place, like albatrosses, as far as I know, cannot hover, but an osprey can hover. And it can take off, and it can, of course, fly like longer ranges and a little bit more efficiently than, say, a hummingbird would. So you kind of see this spectrum also in nature. So, and we're just, essentially doing the same here with our eVTOL. So,
did you know that Collaborative with Spencer Krause now has a merch store? Please go to cwskmerch.com for the latest in CWSK styles. You can get a hoodie, like the one I'm wearing, t-shirts, hell, we even have whiskey glasses. Everything in the store has custom art that our team worked really, really hard on. So go ahead and show your support for them, me, and the rest of the CWSK team by going to cwskmerch.com today. Better yet, support yourself and use discount code podcast10, all one word, all uppercase, for 10% off your entire order. Thanks for your support and enjoy the rest of the show. Collaborative with Spencer Krause is sponsored by SKA Robotics. If you're in the market for elite field robotics expertise, please consider hiring SKA Robotics. They sponsor this podcast and solve some of the toughest engineering problems in the world. SKA Robotics can be found at skarobotics.com.
What's really interesting actually here is the pilot training pipeline for eVTOL. So one of the things, so this is not Archer, this is not us, but others in the industry. So the industry is kind of like become essentially two like main pillars in the eVTOL industry, right? The first is what we're building, air taxis. And the second is what you're seeing actually a lot of companies in this space is these personal eVTOL aircraft actually that are smaller than what the FAA would classify them as an ultralight. And interesting thing about an ultralight is that you don't need a pilot's license to fly that. So there's a company out in California. They're called Pivotal. They used to be known as Opener, I believe, or Blackfly. And they're building a vehicle right now. I think they're taking pre-orders, or I think maybe you can buy them. But essentially, you can learn how to fly this vehicle without having any experience. They'll just take you and they'll show you how to fly this aircraft, and you can go out and fly over the countryside. And there's a really good article actually in the New Yorker about this. This happened, I don't know, maybe 6 months ago or something like that. But this guy was like flying around, and he was talking about like seeing all the cows on the ground and stuff like that. So, which is like pretty incredible. And like to do that with like almost no training.
Want to be able to fly low enough also to be able to see cows like clearly. I mean, the guy must have been, he can't have been that high up at that point.
Oh, absolutely. Yeah, there's actually a company in Europe. They're building another personal eVTOL. It's called Jetson 1. And in their videos, it's kind of crazy, actually. You see him flying through forests and
in between trees?
Yeah, in between trees.
That's insane.
Yeah, it is kind of crazy. It is terrifying. But, hey, I mean, it's pretty amazing that, again, You don't need a pilot's license to do a lot of this stuff. So
Is
I
the
think it's gonna.
training like curve like easy enough that you can just figure it out pretty quickly? I wonder on something like that.
Yeah, it should be. I mean, one of the things we've noticed actually in our simulator, in our Archer simulator, is that we have pilots, we have people that have had no training and just people off the street, and you can just like put them in our aircraft and they can fly it. And the reason why is it's designed in such a way that our computer, our flight computer, is always in the loop, stabilizing the aircraft, always calculating the most optimal like conditions for it to fly in, and it really makes the job a lot easier to do. In fact, we've gotten rid of a lot of our traditional flight controls. In fact, we have two joysticks on the side of our aircraft. We call them inceptors, and it simplifies how you fly and interact with these vehicles compared to the traditional yoke and rudder pedals and joystick and throttle quadrant and stuff like that. Our pedals, for example, don't really do much. They're not like traditional rudder pedals.
What are they there
It's all
for? Like, what do they control?
uh, on the ground brakes. That's pretty
Oh,
much
that's
it.
interesting.
Yeah, yeah, yeah. So
Is it
our
similar
aircraft's
to like
much
an actual
simpler.
rudder where you have to do that for brakes?
No, yeah, we don't. Yep, that's exactly it. So they're just brakes. And all of our controls are in our two inceptors,
So
and
if
you can
you're,
actually,
oh, sorry, I didn't mean to cut you off.
yeah, I was gonna say, if you have the new Microsoft Flight Simulator 2024, you can go and try flying our aircraft in there. Midnight's in there, and just get an Xbox controller, and you can map the two like little joysticks, or whatever, to to that, and you can go fly it. So
That's awesome.
yeah,
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 I
and
do not have Flight Sim 2024, but now I kind of want to get it since you've told me about that.
Many hours later.
yeah, yeah. The Jetson aircraft is in there too. The little personal drone thing, the personal eVTOL, so you can go fly around wherever you want as well.
Between
And you kind of
trees.
between trees, exactly, exactly. So
That's
yeah,
awesome.
hopefully, while you get your pilot's license in maybe a few short years, those other products are going to come to market, and maybe you might future pilots might not need to get their pilot's license.
I'm sure I'm
So
not going to understand the flight controls from a conversation, but just to get a general idea, like, are the inceptors like single degree of freedom each, or like, are they more joysticks, or like, how do they work exactly? Like, what do
yeah,
they affect on the
yeah,
plane, or is that the aircraft?
absolutely. Yeah, so it all depends on the regime of flight it's in, right? So if the aircraft is so it's we've designed our flight controls to be similar to like the Harrier or the F-35, or you have like a unified flight controls, and you have your throttle essentially makes you go forward and backwards, but it's not really a throttle. It has like a center detent. You can see this as well in the Microsoft Flight Simulator game. And of course you have on the other side, you can make the airplane go, bank left and right. But what the actual maneuvers are, it kind of blends. We blend the hover when the aircraft is flying around like a helicopter, and to when it becomes like an airplane, with analogies where when you're in hover you can like rotate around a lot easier, you can like twist the aircraft, versus when you're in an airplane, you're say using your rudder pedals, right? Or you've got other sorts of like side slip you want to try to to do. So we kind of do a very a smooth blending between hover and when it's flying around like a helicopter, and like an airplane mode, and the airplane modes. And we do that in such a way that it's easy for any pilot. Of course you got to have, for us, your pilot's license to fly either airplane or helicopter. And then of course it should be easy for them to be able to be trained to get their powered lift rating for a vehicle of our class. But for someone off the street, I'm sure that a lot of these other smaller companies are probably adopting very similar methods as well. So, but yeah, they're just normal joysticks. So essentially,
That's awesome.
yeah, yeah, it's
Yeah.
very easy to fly.
Yeah, I kind of want to try it now in Microsoft Flight Sim. I mean,
Yeah, yeah,
obviously want to try it in real life, but that seems like a bigger lift.
yeah. The Joby aircraft is on there too, actually. So, and Joby, they have more of a. I'm not an expert in their design, but at least in Microsoft Flight Sim, they do have like a throttle essentially, on the left, and a joystick on the right. So, which is similar concept of unified flight controls, but they've taken we've taken a different approach to, how we have our inceptors essentially designed. So
That's pretty cool, though. I mean, like, I guess the fact that we're early enough in eVTOLs that there's not like a single way to fly them all.
mhm.
And I mean, I guess that's true of like more mature aircraft as well. Like, there's just what makes the
Yeah,
most amount of sense to the designers.
absolutely. You see this as well in the architecture of these aircraft as well. So, for example, there are eVTOLs that are purely rotor, like helicopter, like similar, like they don't have any wings, right? So, companies like Volocopter or Jetson, for example, they don't have any wings. They're just pure, lift rotors, or EHang, which is a Chinese company, right? And you have Joby, where all their rotors or all their propellers are all tilting. They're all six of them are moving, and we kind of have a hybrid between, like, some of ours are tilting and some of ours aren't. So there is no consensus even on aircraft architecture right now, as to like what that is. And of course, there are positives and negatives to all of them. But yeah, it's really it's still very much, we'll have to see kind of how all these things develop over time, and kind of what the trade-offs are for that. So yeah.
Yeah, for sure. No, I mean, that'll be interesting to see kind of like, 50 years from now, what's going to be the standard, or are you going to see like divergence and, a few different paths of different classes of eVTOL?
Yeah, of course. I mean, Boeing's like, a Boeing and an Airbus, just on first glance, they look very similar, right? You got a big tube, wings, two engines, great, very similar architecture. But of course, the detail is all in, like, the performance differences are all in the details, really. So how much more drag can you get rid of, and the way you shape the wings, or like this little part on the aircraft, the cowling, for example, things like that. All these things play a difference at that point in a more mature industry.
Yeah, that's pretty interesting.
Yeah, yeah, of course. So
So,
yeah, well, go ahead.
after you.
No, no, yeah. So I was gonna say, so I just have to see how things shake out. That's it. Yeah.
Yeah, for sure. I was gonna say, what point in your life did you know you wanted to go into aerospace?
That's a great question. So I have always dreamed of what this world would look like to try to build these type of vehicles. Just the idea of, you know, how do you like, how do you get, like, I've always dreamed of the future where anyone can fly whenever they wanted, on demand. Like, if you want to go flying today, or if you want to go fly across the city or whatever, fly across the town or country, whatever, you can just do that. Um, and that's always been like one of my motivations. So, like, figuring out how to do that. But I was in love with aviation since I was, like, even before I can remember. So the earliest memories that I have is, like, I remember playing Flight Simulator actually with my dad. Like, I was sitting on his lap and I was like trying to land an airplane. I couldn't do it very well. That's, I mean, since I was a young kid, and after school, when I grew up in the Caribbean, and while after school, most days after school, I used to go to the airport and just, like, hang out there by the airport fence. And this is a small airport in the Caribbean, of course, so you can see people, like, coming in, on and off. So I used to chat with the pilots, and I got to know the air traffic controllers. So I got invited to the tower a bunch of times, and
Oh, cool.
even, like, go to the ramp. And yeah, it was just like, I was just in love with aviation, So I could do, I did a lot that I could just kind of keep me around. And of course, as a kid, I didn't know how to fly an airplane, but I did really get into Microsoft Flight Simulator. So I made a bunch of add-ons and stuff like that. And so, just try to build the world that I was, like, living in, essentially, so I can, like, dream about just, like, flying around. So this was in the 90s, early 2000s. There weren't a lot of, like, Caribbean flight simming wasn't really a big thing. So, I was like, you know what, if it's not here, someone's got to do it. Right. So let me go ahead and just start building out these, the different aircraft or whatever, the airports and stuff like that. So since as far as I can possibly remember, I've been in love with aviation. So
That's awesome. I was about 12 when I built my first robot. So
yeah, there it is. That's awesome.
No, it's palpable. I mean, hearing you talk, it's obvious that it's like a lifelong passion. So
Yeah,
curious.
yeah. And we're really excited. Hopefully, this year, 2025 and your 2026, we can really, you know, get this thing off the ground with, people, passengers flying here, and it's gonna be really great. So
Yeah, that's awesome. So, I guess extracurricularly, what are you into outside of work?
yeah, it's a great question. So obviously, Archer Aviation, San Jose, California, right? We were originally in Palo Alto, then we grew out of that and moved to San Jose. So California is the Golden State. So it's amazing for how much you can do outside of like the work. One of the things about Silicon Valley is that everyone works really hard, and of course, everyone works really hard at Archer as well. So during the week, we're working really hard, we're heads down, grinding. But when the weekend hits, it's like that is the time when I just like love that. So there is so much to do there. I mean, it's
Oh yeah.
unbelievable. So like for the first time in my life, so I grew up in mostly tropical climate, obviously the Caribbean, Florida. So the first time in my life, I was actually able to do like a winter activity, winter sport, and like a summer sport, which was like incredible. So in the winters, like I went skiing like every weekend to Lake Tahoe, which is like incredible. Of course, Palisades, and there's a bunch of other ski resorts, Alpine Meadows, and of course the Epic Pass resorts, Heavenly, North Star. They're incredible. And in the summer, being in the Bay, you're right next to Santa Cruz Mountains, and there's incredible mountain biking trails out there. I mean, you can really kind of bike all summer long, or all year round, but it does kind of get cold and like wet, I guess, in the winter. But yeah, I mean, mountain biking. I picked up kite surfing as well,
Oh,
or
cool.
kiting, kiteboarding. Yeah, it's all the rage actually out there, and it's kind of funny. My old advisor, my PhD advisor at UF, he was a big windsurfer. So he used to actually windsurf in the same spots that now it's been taken over by kiting, which is like kind of cool. So I've been able to just kind of talk with him about that. So it's been really, really neat. So yeah, just adventure sports. But right now I'm back in Florida, just for the time being. So my wife is in graduate school here, and of course, I think it's really important to kind of be together. So while I'm here in Florida, try to do some mountain biking. So
That's awesome.
yeah, the hobbies that I'm also really into is actually making like historical recipes.
Oh, cool.
And then so like figuring out. So the way that I see it, right? We can travel the world, we can travel to other places, right? But we can't really, unfortunately, travel through. We can travel through space, but we cannot travel through time. Hopefully, maybe one day humanity can figure it out. But
I don't think we're anywhere close.
Exactly. But one of the ways we experience different spaces, different places of the world is through cuisine. So I figured one way we can experience different times is also through cuisine. So, finding recipes of what people ate like 200, 300, 400 years ago.
That's awesome.
And kind of having a slice of that, or, eating that. And it's just really cool. Flavors are just really different. Spices obviously are different. It makes you really feel blessed to be living in this era, to be honest with you. That's the biggest takeaway that I've gotten out of it.
Moses, how do you access that information? Like, is it just like finding cookbooks from a while ago, or like people's diaries, or how do you figure out what to make?
That's a great question. So there's a pretty big community of these historical cuisine people, honestly. If you just like go on the internet and you just find, like, you can just go to Google, honestly, and just type in like historical cuisine. There's a really good cookbook. It's a YouTuber. His name is Max Miller, Tasting History. He has a big YouTube channel, pretty big following. He's taken a lot of these recipes from the original sources, like, these old 18th century cookbooks, and kind of has taken them and made them again. And of course, you can go back to the source as well. Like, a lot of these things are open source, open domain, public domain, right? So a lot of it's on the internet. Honestly, you just parse it through ChatGPT and update the recipe, and you can do it. A lot of YouTubers, a lot of folks on Reddit that have taken these things. I think I got a gingerbread recipe from the 1400s or something like that I found on Reddit or whatever, and then I remade it, and I was like, that was pretty cool.
What was the difference between like a gingerbread from the 1400s and like one you might, purchase at a grocery store in like 2025?
The spices are really different. So the gingerbread had a lot of like pepper in there, which is really interesting.
Oh, that isn't like black pepper?
Black pepper, exactly. So if you think about it, right, like, this is back in the day, like, if
what
you
was the
had
country of origin? Sorry, I didn't mean to
I
cut you
think
off.
it was England. It was
Okay,
English, I
cool.
believe. So I think it was English. So
When they would have had
um,
access to sugar at that point because of, you know.
so interestingly enough, is it called for using honey
Oh, that
as the
isn't okay.
base. So, and of course, this is a food meant for kings at this point because like you got to harvest honey, you got all these like random spices, in there. So it was very, very interesting. It didn't taste much like a modern gingerbread would taste like. It was made from like stale bread, for example. I used to use breadcrumbs, but it's kind of got the similar flavor. You take honey, you boil honey, you add like tons of breadcrumbs, you add the ginger and the pepper, and you let that cool. And
Huh.
yeah, and then you have your gingerbread. It's more of like a ginger chew
Yeah, I
than
can
I would
imagine
call
there's
it.
no way for it to rise at that point with
E-
that recipe.
Exactly, exactly. But it's gingerbread. It's got ginger. It's got bread in there, so it's what we consider that. So yeah,
I
it's
got a recipe. Oh, sorry, I didn't mean to cut you off. I was gonna say I got one from a bartender a while ago, for a ginger simple syrup,
oh
and the
nice.
way that they made it, which I really liked, was like, you know how like sometimes like normally when you make simple syrup, you'll boil down sugar and like maybe some other ingredients and
Mm-hmm.
equal parts sugar and water, right? That's like the base recipe.
Yep.
So this one was, you take sugar and you stick it in a blender with equal parts water,
Oh,
and you
interesting.
never cook it. And what I found when I made that recipe is that it resulted in a much spicier flavor because you didn't end up doing that thing where the ginger mellows out when you cook it.
Yeah.
So that was kind of good. And then when you make that, there's a byproduct in that you have to run it through a strainer to get all the pulp out of the ginger,
Mm-hmm. Mm-hmm.
and the leftover pulp has a lot of sugar and ginger in it. So if you cook that on a silicone mat or like in a pan, you can make like a ginger chew,
Oh,
and it's
no
just
way.
yeah, it's
Oh,
just
that's
ginger pulp and
fascinating.
sugar, and it's very
Yeah.
good. And so when you describe that recipe, that's like
Yeah.
kind of my head went to that.
I mean, if there's one thing I love about humanity is that if it's a good idea, others were gonna always try to do the same thing. So,
Yeah, or something that kind of resembles it. Yeah, exactly.
yeah, exactly.
Yeah.
But yeah, no, it's pretty amazing. I like that cooking, and it's just cool to be able to think about, how this, how we can, what our ancestors lived like, and also like, kind of meta, like how do we fit into the greater arc of, human history and human time. So it's something that, just always
I mean,
think about.
the
So
crazy thing is, like, I would imagine just going back into historical cuisine because I didn't know this was a thing. This is really fascinating to me.
yeah,
But I would imagine that, like, when certain ingredients are referenced in historical recipes, they don't necessarily mean the same thing that they would mean now. So, like, mainly because, like, you'll have, like, plants that have died off and, like, don't exist anymore, or, like, maybe just a different vernacular, or, like, maybe there's, like, a different breed of, like, I don't know, corn was, like, a New World crop, I think. And so it
yeah.
wouldn't have even existed, but maybe if somebody mentioned it, they meant something else. Like, I'm just speculating here.
Yeah, for sure. So, I've never made it, but the making garum, which is like an ancient Roman, item, it's pretty challenging to make, and I think basically, I think there are some ingredients that are hard to get, hard to come by. There's like modern versions of garum, but they're very different. They're different in to some extent. They're different, but it's a challenging process. It's not easy. Another one I remember looking at, this recipe called for mace. So mace is the shell of the nutmeg, essentially,
Right.
and that's also kind of hard to find. I feel like I'm not really, it's hard to find them at grocery stores and whatnot. So it's just like sometimes you just got to make like thoughtful, substitutions. The most recent recipe that I made was, you know, thanks to Max Miller and his tasting history, basically is this pumpkin pie, right? Pumpkin pie is around Thanksgiving, and it's like an early pumpkin pie. But the recipe called for basically just like herbs. It doesn't specify what those herbs are,
Just
So,
whatever you think feels right.
exactly. So,
I mean, to be honest, like we have the luxury of being able to access like pretty much everything in the world through air freight and refrigeration and
yep.
freezing and so I mean we really have it pretty good in that regard. Like I don't think any other point in history you had access to the same range of stuff that we can get now, like in just in
Oh,
one locale.
100%. Yeah, we are living in such an incredible era of like history of like being able to enjoy good food. The one thing that I've seen all throughout like my cooking adventures throughout time is that man, food tastes so much better in the modern era. It's based, cooking techniques are different, ingredients are better, like one example is like apple pie recipe that I made had like cloves in it. I don't really think cloves like really go well in an apple pie in my opinion, you know? So,
But it must have
it's
been what
like
they had around, like within
exactly.
arm's reach, because you couldn't
Yeah,
go more than 5 miles in any direction, or you just lived there after that.
exactly.
Yeah.
So I was like, oh man, I'm just so glad. Food tastes so much better. But you should try it out actually if you're curious. Yeah,
Oh,
definitely
I
check out.
definitely am.
Yeah.
So,
So it's really, really fascinating. I really enjoy that. So
yeah, that's awesome. I'll have to check that out. I mean, I do love to cook. If I didn't go into robotics, I mean, the other career path I considered was being a chef, and so
really,
yeah, like in my 20s before I realized how much more money I'd make in this field, and I both were passions of mine. Like I really love to cook, and I also really love building robots and
yeah.
designing them. And what are some of the things you've seen, like just through like historical aviation and just different, aircraft and spacecraft over the years that have kind of captured, your interest? And like, what are you a fan of? I mean, you mentioned the V-22 Osprey. I
Yeah.
mean, obviously there's Midnight, but like, what else?
Yeah, no, it's really interesting. I think about the aircraft that have really like changed the game. So, there's the de Havilland Comet. So the
I'm not familiar
Comet
with that.
was okay, so the de Havilland Comet was the first jet passenger aircraft, I should say rather. So that airplane really, really pushed the frontier. So back in well, and of course the 707 was right after that, the Boeing 707. But that aircraft ushered in the jet age, right? So before that, people were flying around these prop planes. It used to take like, I don't know, 17 or 15 hours, like a DC-6, DC-4 to cross the Atlantic Ocean. It took forever, right? And then planes were really loud, really noisy, and it just took a long time. And of course, you have the very first jet aircraft, the de Havilland Comet, that brought us into the jet age, where you essentially take that, say, 15-hour, 17-hour flight, whatever, and you cut that down by like 5, 6 hours and do it in like 10 hours or so. The de Havilland Comet didn't have the range to do that, but shortly thereafter, of course, the Boeing 707 came into play, and of course, 707, crossed the Atlantic Ocean back and forth. The Douglas DC-8 as well. So, what I think is really interesting about those aircraft, right, is they
That's not what
changed
I
the
would have
game.
thought you would have named as passenger aircraft. That's
Yeah,
interesting.
exactly. Yeah. But what really made those special actually is their propulsion. Their propulsion is what really changed everything, and I think we're seeing the same thing right now with eVTOL. So we are now going. There's a marked difference between reciprocating engines and jet engines, and now I believe there's going to be a marked difference between reciprocate or jet engines and other reciprocating engines still around today, and electric aircraft. So electric aircraft are obviously much cleaner, much cheaper, hopefully cheaper to operate, and just overall better. And in the same way that, jet engines brought people across the Atlantic much faster and kind of opened up aviation to like far off destinations, I believe that the electrification of aviation is going to open up new frontiers in, the democratization of this field, where instead of, paying like, I don't know, $200 an hour for getting your, like to get your pilot's
Yeah,
license or
it's around
whatever.
what it costs.
Yeah, it should be hopefully a lot cheaper once you have, say, electric fixed wing aircraft. Now, these are not eVTOLs, but we're in the same kind of industry, electric aviation. But hopefully, it should be a lot cheaper. So I see the past, and I am that really gets me excited about the future in terms of aviation as well. So,
Yeah,
yeah.
that's awesome.
I do think that reinforcement learning, AI, all these things that's going to change the world. It remains to be seen how that impacts like vehicle autonomy, really on our end, or like they're like for example Tesla on they're going fully, I mean, I don't know the in and outs, the details of their autonomy architecture or autonomy stack, but from what I understand from being on the outside, and what I see is I believe they're just essentially building, these models to they're looking at millions or hundreds of hours or whatever of like road data and then trying to figure out how to drive, which I think is a really interesting way of approaching the problem. So I would like to see kind of how all these things, kind of bear out. I think RL has, a lot of really interesting applications. I think we're just kind of scratching the surface on. One thing that really kind of took me off guard, actually, really was surprising to me, was OpenAI's O3 model with their breaking the ARC AGI benchmark that happened, I don't know, a few months, like a month ago or something like that, where they're able to like solve these like really interesting puzzles that, it was one step towards AGI, essentially, as they call it, right? So I think when you have these models that can understand things, now, of course, they're based on text or based on like thoughts or whatever, or thought processes in the case of the O series model, like chain of thought. If you can kind of apply those algorithms and put a ton of compute into it, it makes me wonder like what more can they unlock, so I think that should be really interesting to see how that industry kind of plays out in the not just in the world of software, but in the world of physical atoms, with like robots as well. And of course, I don't know what that looks like in the aerospace industry. We're definitely, we are not going to be like we're going to be flying with pilots we're going to be flying with pilots on board our aircraft and whatnot. But, it would be interesting to see what autonomy would look like eventually in our industry as well. Some of our competitors, like Joby, for example, they recently acquired this company called X-Wing. And X-Wing they built an autonomous like prop airplane, and they're going to try to figure out like what autonomy looks like in the eVTOL space. And I definitely feel like it's one of those things that we will figure that out at some point, but what that looks like is unknown. And I think there's a lot of changes in this industry right now that we'll have to see kind of where things shake out, and it makes me excited about the future of like robotics. I guess it's definitely not, it's definitely one of these things right now. We're being very deliberate in how we place our vertiports, and of course we're gonna have pilots on board, certified powered lift commercial pilots, and it's going to be really interesting to see kind of the mix of regulation, how that influences our industry as well. Obviously, aviation is the safest form of transportation, like period, right? Like there's not even anything close. So we've got to be able to maintain those high levels of safety and high levels of community acceptance. So we're taking a pretty measured approach to like how we approach a lot of that stuff. So I think that's smart. But I'd love to see, maybe it's hard to predict the future, as you were saying, But
yeah, I don't know. Like everything I said that was going to happen, like I don't actually know that's going to happen. Like it's just like a hunch.
Exactly.
Yeah.
So
now I get to answer that question on interviews a decent amount, and I like that you flipped it on me in my own podcast.
Yeah, of course.
Yeah, I'm like, I don't know.
yeah, but
cool.
Yeah, a lot to look forward to. So
awesome. Well, that seems like a good note to end on. Is there anything you want to plug as we kind of head out the door here?
No, I mean, I think, I really appreciate you having me on. It's been great getting to be on the podcast, getting to know you a little bit, Spencer. And, I'm excited to see what the future holds. And, in the words of, I think it's Doc Brown from, Back to the Future, right? Now, where we're going, we don't need roads. So let's hope that, we'll hopefully make that dream become a reality. So.
Awesome. Well, hey, Moses, thanks for coming on. This was an absolute pleasure. Really appreciate it. And where we're going, we don't need roads.
Exactly.
Thanks for joining us today. If you've made it this far, chances are you'll like other episodes too. Collaborative with Spencer Krause is available on YouTube, Spotify, Apple Podcasts, Google Podcasts, Pocket Casts, and Radio Public. Subscribe today to get notified when the latest episodes release and support the channel. Collaborative with Spencer Krause is sponsored by SKA Robotics. If you're in the market for elite field robotics expertise, please consider hiring SKA Robotics. They sponsor this podcast and solve some of the toughest engineering problems in the world. SKA Robotics can be found at skarobotics.com. Thanks again, and see you on the next one.